Hi, Helen, how are you doing?
Hello, I'm doing well. How are you?
I'm doing fantastic. How is school and
Good.
everything?
Glad to hear it. School's alright. I mean, I've just been working on my algebra homework all day,
Oh, I see.
and
How is it going?
yeah, it's been tough.
Oh,
Um, but yeah,
okay.
I've been really stuck on this problem. Would it be okay if I shared my screen?
Yeah, sure, of course.
Okay,
Let me allow you to do the
you do
screen.
that? Oh, I can. I can. It's all good.
Oh, are you good now? Okay.
Yeah, I can share. Okay. So yeah, I'm having trouble with this problem.
It's saying, if I can just read it out loud, a formula for calculating the
Yeah.
distance d in miles that one can see to the horizon on a clear day is approximated by the formula d is equal to 1.22 root x, where x is the elevation in feet of a person. So if a person climbs a cliff and stops at an elevation of 200 feet, how far can the person see to the horizon? Okay,
Yeah.
so
I just have no idea where to start.
okay, that's why we're here. And
Yeah.
we have d. Remember, d is equal to 1.22 root x, right?
Uh-huh. Okay.
Your d is equal to 1.22 root x, right?
Yeah.
But remember, they're saying the person stops at an elevation of 200 feet. Remember, what's representing elevation? So the first thing is to understand your variables. You have
Yeah.
d and x. So
Okay.
d is the distance that one can see to the horizon on a clear day, right?
Okay.
And
Okay.
x is the elevation.
Okay. So if x is the elevation,
Yeah,
d is the distance, then I guess we just um with the 200 feet, would that be x?
yeah, exactly. You got it.
Okay. And so
200
for
feet.
this problem, do we just like want to solve for d?
Exactly, exactly. You got it.
Okay.
But I think
Cool.
you've got the whole idea. The only thing I think you should just know is to know the definition of the variables, what d is representing and what x is representing. So
Oh,
once
okay.
you understand that, you are good. So just like
Okay.
you quickly figure out what x is, and you quickly figure out that 200 feet is representing x, and that's what exactly we need, right?
Okay. That makes sense.
So what is
So
d?
then
Let's
this would just be 1.22 times root x times root 200, right?
times
Which is 40, so times, I think it's 40.
that will be 40. 40 times
Yeah, it would
180.
be 40, yeah.
Only the calculator here, but
So then 1.22 times 40, that's like 400 and, or 40, 48.8?
40.8. Yeah.
48.8, yeah.
So that will be a distance, 40.8. And what do you think are the units?
Uh, feet. Miles. Oh, miles. Oh, yeah, okay, miles. You're right.
There you go.
That's right.
And part B, did you
Is
get that part?
is that it? Is that it for part A? That's it?
Yeah.
Okay, and so then for part B, would it just be the same thing? Like we have 25 miles, and so then 25 would be x. So it would just be d equals 1.22 root 25, like that.
Yeah, but this time around, they're saying how high should the person, they're asking for the elevation.
Oh, I see. So they're asking for the, okay, so then they're asking for x.
Exactly.
Okay, and so then the distance, so then, um,
So it's like they gave you distance.
oh, the distance in miles, and then here it's miles.
Yeah.
So then D, we can see that D is 25. Oh, okay, I see. So then it's actually
Exactly.
25 equals 122 times root x.
Excellent.
Okay.
And
So then from there, I know that I'm supposed to like divide both sides by 1.22, right?
Mhm.
But then how do I get rid of the square root here? I don't really get.
Okay, so remember, if you introduce square both sides, what happens to the square root side?
Oh yeah, because then you can just square that,
Yeah,
and then the square root goes away.
exactly.
Okay, I see. And so then this is our answer.
That will be your answer. You can, if you want, you can simplify it further.
Cool.
You do have a calculator there to see what you
Yeah,
get.
let me check.
Divided
Uh,
25 divided by 1.22, then you square that.
and then that squared, it'll be 419.914. Oop, 914. So is this our answer?
Did you square it?
Yeah.
Ah, that's pretty good then. If you did, that will be your answer. That will be your x value there.
Cool.
You
Okay,
need
so
actually
this
see that amount of distance there. And what are your units, by the way?
feet, right? Feet, because we have x's in feet. Oh, okay. That's a good point. Always remember units. I forget units all the time.
Got it. You got it.
All right.
Yeah, I think you had the idea though. You had everything, you had the idea, but maybe you just remember what each variable is representing. Once you do that, you're good to go.
Okay.
Everything else is simple algebra,
Okay. Thank you. Yeah, I'll make sure to always like underline my variables or circle my variables and my units before I forget them. So
Usually,
yeah.
unit also can guide you to know what kind of variable is being required, stuff like that.
Uh-huh.
The units could be very helpful. For example,
Okay.
miles there was representing the distance g, and the feet was representing the elevation x. You see?
Yeah, that makes sense. That's right. Because then you can kind of match them, like depending on what the question asks. So, like for here, right, the miles.
Yeah.
It's asking for miles, and that's how you can tell that. Okay, yeah, that makes sense. I see that.
Of course.
Thank you. Okay, thank you so much for your help, Alvin. I really appreciate it.
Do you still need something? Is there another question that you want us to go over so that?
No, this was it. This was good. That's all I got.
Oh, that sounds good. Thank you very much for
Yeah.
your share. Thank you so
Yes.
much.
Thank you for your help. I appreciate it.
So much. Have a good day.
Yeah, you too. Hi, Alvin. How are you doing?
Hi, how are you doing, Helena?
I'm doing well.
Uh,
Um, how is school going? How is stats going?
States is going okay, but we have some few ups and downs. Some problems could be a little bit challenging, but yeah. So I have a problem that I want you to help me with.
Okay.
Is there a way that I can share the screen?
Yeah, the little green button at the bottom that says, yeah, just hover over the bottom and then it'll say share screen.
Then I think. Okay,
Are you able to share?
or let me send you the question, right?
Okay.
Yeah, actually got it. Actually got it. Let me
Perfect.
see. So, can you see my screen now?
I do, yes. Yes, perfect.
So,
Okay, cool. Yeah, I see the problem.
let me see a way to share the problem.
I see it right there.
I sent you the problem.
Sorry?
Did you see the problem that I sent you?
Yeah. Yeah. I have it. Yeah, I have it, and I see it shared on the screen. And yeah, you sent it to me, so I got it.
Okay, that one. So that's the problem that I'm having problem with. I tried to solve it somehow, but it's not.
Okay.
Yeah.
Yeah. Yeah, I get that. Um, so there are a couple of parts to this problem. first of all, what would you say is your approach to this problem? Like, what's the general category of this problem? What chapter are we on? Like, what are we learning about? Is it binomial distribution? Is it normal distribution? What are we doing here?
It's more of binomial distribution, but with a little bit of approximation to normal, something like that.
Yeah, so this will be more normal distribution.
Oh, this is normal.
So this is normal distribution.
Okay.
And the way that you can tell that is, actually there isn't really. It usually says it will be normally distributed, but this is normal distribution. This is specifically from the central limit theorem. So it's a central limit theorem problem. And we've been working a little bit with central limit theorem in the class, and it's actually a really important concept. But anyway, so the way that we would go about this is, I think the first thing to do would be to, for one thing, identify all of our variables. So identify, we have mean, right?
Mean there, right? It is the average.
Yeah, the average. Exactly. The mean is the average. And then we also have the standard deviation,
which is 2.5, right?
2.5. Yes. Perfect. So then the mean would be 17.2.
17.2.
Okay. And then we also have, sorry?
Well, I said both of them are in pounds, right?
Yes. Okay. Yes, in pounds, yeah. Yeah. The units aren't that important in this case, but yeah, it's in pounds.
Okay.
So mu, and we have our mean, and we have our standard deviation, and we also need our x. We also need our n, since this is a central limit problem, central limit theorem, but we would need our n. And our n is just the sample space. So it is how many units are in our sample. So in this case, we have a sample of 55 families.
Okay, exactly.
55. So 55 will be our n. Here, n. Okay. And we have mostly everything. We actually have everything that we need. Okay. But now what we're trying to do is we want to find the probability, right? The probability. So in these problems, in these normal distribution problems and central limit theorem problems, the two things that you will always be trying to find will be, actually, you will always be trying to find one of two things. You will either want the probability or you will want your x values. So in this case, it says the probability. So what we're looking for here is the probability. And we want to find the probability that the mean will be between 17 and 18 pounds.
Oh, I see.
Here, okay. So then what we have here is this is what we're trying, this is just in like math language. What we're trying to find is P of 17.
So confirm X lies between 17 and 18.
Yes, exactly. X yeah, X bar will be less than 18. Or 18. 17. And this X bar here, this denotes the sample mean. Actually, I'm just going to write it here. Okay. This is the mean of the sample. This is X bar. Wait, why is my red disappearing? Okay.
You got it?
There you go. Yeah. Mean of the sample is denoted by X bar. So that's what we find here. So that's what we're trying to find the probability. And so in this case, we have all of our information and we're trying to find the probability. And so what we need to do is we need to look in the chart, right? We have that standard standard normal distribution chart that we need to look at, or you can use your calculator, but I think that it would best to look at the chart for this case. And so what we do is we then we in order to look at the chart, we can't just look at the chart and like try to plug these values in and look at the chart. We actually need to find something called the z-score.
What is this? Oh, I see.
Yeah, and oops, I did not that one. But anyway, the z-score is an intermediate step from the probability, or from x to the probability. So what we want to do is we want to find z. And we have this nice formula here, which is z equals mu. No, sorry, z does not equal mu. Z equals x bar minus mu. And this x bar, remember, is the mean of the sample. And this x bar is only for the central limit theorem problems. So when it's not a central limit theorem problem, when it's just an individual, when it's not a sample, when it's only an individual, then you don't have the bar. You just have the x.
I think that's another part that always confused me. Was some of the problems I see the X bar, and the other ones I don't see the X, and I was like, what's going on?
Yeah.
Now it's starting to make sense now.
Okay, I'm glad. Yeah, the X bar is it's just to denote the mean of a sample, and just like you'll see on your calculator, it says X bar as well, and that's what that means. The mean of the sample. You'll see both of these, so you'll see.
Oh, I see. Oh,
So this is the mean of the sample, and this is the population mean.
Okay.
That's one way to remember it is what you see on the calculator. Anyway, so then we have our z, and let's finish writing out our z z-score formula. So then our z-score formula is x bar minus mu divided by standard deviation over square root of n.
Okay. Which is the sample space, right?
Yes.
Oh.
Yes. And so we plug in all these.
Wait, I sometimes see that maybe I am wrong, but there's other problems that I just see them right divided by sigma, which will be divided by standard deviation, and they don't put that there. What kind of division is that?
Yes, excellent question. So the thing about this root n is that this is only for the central limit theorem. So the root n is when you actually have this is actually the standard. This is the standard deviation of a sample. So the standard deviation of your sample x is equal to the standard deviation of the population divided by square root of n.
Oh, I see. Oh,
yeah. And so that's what. Yeah.
I always struggled and scratched my head, and I was like, like these kind of things. Only it's that easy.
Yeah, it can get complicated because there's so many different formulas that you have to memorize, and so the mean is a lot easier because the mean of the sample, if you have mean of x bar, the mean of the sample is the same thing as the population mean. So this one's easy. But then this is what you have to memorize. So really what we're doing here is we're doing z times the sample, right, is equal to our x bar the mean of the sample divided by standard deviation of the sample. So it's the same exact formula, except it's the standard deviation of the sample. And this is the same thing as that.
Oh, okay.
You plug the formula into here, and you get that.
Oh, I see.
So, Okay, so this is our z-score. So then we have to find the z-score. So now we plug it in, and we have our x bar minus mu divided by standard deviation over root n, and our mean is 17.2, standard deviation is 2.5, and is 55. here, our x bar, well, we actually, because this is looking for an interval, we actually have two x bars. We have our x bar, we have our x bar 1. Where did my arrow go? Okay, we have our x bar 1, and we also have our x bar 2.
Mhm.
We need both of these.
Well, because it's a range, right?
Precisely, yes, exactly.
It's more of like an upper limit and the lower limit. Confirm?
Yeah, exactly. It is the lower limit and the upper limit. And so that's why we use them. We have to use them both. And so since we have two x bars, then we'll also have two z's. So then we have to find z1 and we have to find z2
Is it
and z1. Use x bar 1. So then we use 17 minus 17.2.
Mm-hmm.
All of that divided by the standard deviation is 2.5.
Divided by square root of 55, right?
Exactly. Yes. Divided by square root of 55. My things keep appearing. Go ahead. Okay, and then you can work that out on your calculator. Or I can later, whatever. And so then for this one, it's 18 minus 17.2. That divided by R5 divided by root 55.
By 55.
So if we work all that out on our calculators, then let's see, what do we end up with? We end up with
My calculator is so bad that I don't know what happens. Where's my calculator? Do you have a calculator with you there?
yeah, it's fine. I got it.
Oh.
I think. Um, I think. I think I got it. I don't got it. I have my phone. Yeah, it'll be fine. Okay. So I just have 0.2 divided by 2.5 divided by square root 55. So then here I get negative, so I'm just going to write it out here. Z1, I just get negative 0.5933.
Oh.
Actually, we want to round our z's to 2 decimal places. So let's just do 59. So we have negative 0.59, and then our z2. Again, it keeps disappearing. And then we have our z2 equals, this will be 1.2 divided by 2.5 divided by square root of 55. And yeah, when you're doing this on your calculator, make sure you use parentheses.
Parentheses, right?
Yeah.
Yeah, because
Always remember.
I realize that I sometimes have some problems when doing, because I think statistics, it requires very good use of calculator, because if you make a mistake somewhere,
Oh yeah.
You won't get the answer right. And
Oh yeah. That's exactly right. You make one tiny calculator mistake and it messes up your entire problem. Okay, so then we end up with Z1 is negative 0.59, and then Z2 is 3.56. And then we want to go over to the Z distribution tables, which I'm gonna go ahead and share. Let's find them first. You want to use the Z distribution tables, which is table E. Go ahead and share my screen. Let's do this.
Or is there a way that I can, yeah. But I think,
Yeah.
yeah,
Let me just take the screenshot of this.
yeah.
Okay. I think you should be able to. Can you stop sharing just so that I can share my screen to show you the distribution table?
Of course. Let's stop.
Okay. Thank you. Share. All right, so here are distribution tables, and then we go to Z,
Mm-hmm.
table E, and then we see, well, we look first for Z1, and Z1, you'll recall, was negative 0.59. So we want to go into the negative distribution table, and we have negative 0.5, so then we go up here. I'm going to just go ahead and annotate. So we have negative 0.5, and then we want to go all the way to the end, because then it's negative, then it's 0.9.
Oh,
So then, notice here, you have the 0.9 here. You have the 0.9 here. So we just want to go all the way to the end. So let's find it again. Oop, not that. So then we'll circle our solution, and it'll be 0.2776.
yeah.
Okay, interesting. And then we have point. Then we have our 3, sorry, and then our Z2 was 3.56. So then we go into our, here it is, the positive distribution table.
Okay.
And we see that it is 3.5 will be 1. So it says here for values greater, so for Z values greater than 3.49, use 0.9999. So let's go with 0.9999. So here we had our Z. Oh shoot, I already forgot what the first Z was. The first Z was 0.2776, right? 0.2776 was Z1, and then our Z2.
That will be our probabilities, right?
Or sorry, yes, probabilities, yeah. Probability 1, not Z1. What am I saying? Probability 1. You are on it. I am not. P1 and P2. Okay, probability 1 and probability 2 is 0.2776, and the P2 is 0.9999. 9, it's like a 4, but 9.
Wow.
Okay, and then since you want to find P, is the probability that it's in between 17 and 18, right? Less than X bar, less than 18.
Mm-hmm.
Well, then you just want to take P2
Mm-hmm.
minus P1.
Mm-hmm.
And so then that turns out to be, what does that turn out to be? 3, 2, yeah, 2, 7.
Mm.
Okay. And then that should be the right answer.
That'll be, yeah. Wow. Wow.
Or something like that.
Nice.
So yeah, that'll be the process. In the book, it says,
I like the cooking process, you know.
yeah.
You explained it in such a way that I now understand the procedure. Because initially
Thank you.
I used to be very confused and say, why do they do this and why do they do this? But
Yeah.
now come exam, and I always wonder why I don't come for tutoring sessions. But from today onwards, to be honest, what sessions do you want to? Can I come for when I need extra help with it? Because
Oh yeah.
You nailed it on this part. You made me understand this concept so well.
Oh yeah, I'm so glad that I'm so glad that that was helpful.
Yeah.
So I have drop-in tutoring on Fridays from 12 to 2 that are specifically for Emporium students.
Oh, I see. I see.
12 to 2 p.m. Yes, I do.
Yeah.
My coworker, for statistics, my coworker Abel has them Tuesday and Thursday mornings from 10 to 12 a.m. And then for algebra, my coworker Alvin has them from 6 to 7 every weekday from Monday to Thursday.
Oh, that's wonderful. So
Right?
we've got
Yeah.
a lot of opportunities. This, I
Yes.
think, the people always say pumpkins falls to those who have no clay pots. Like certain
Yeah.
people who have got certain advantages or who have got certain privileges, they don't want to utilize those privileges because,
Yeah, that's true.
like what we are saying, there, you guys, you do offer tutoring both in Emporium. Then from there you go to the daily drop-in. I think I will consider coming more of it, and I really want to utilize this time.
Yeah, you should. Absolutely. It's really good. I mean, we've both been talking about how like people aren't really coming to our sessions and it would be great to have more people come to our Emporium sessions. So yeah.
Yeah,
Um
definitely come.
Monday through Thursday night for algebra and Friday afternoons for stats.
So I see. Yeah, because I really like the way you explained this problem. You
Thank you.
stage to stage, stage to stage, stage to stage.
I'm
Ah,
glad it was helpful.
now I think I'm now confident on this part of problems. Yeah, being able to understand because I used to have some confusion on whether to say
Yeah.
divided by sigma. Then you clearly clarified the situation where I use sigma divided by square root of n, and that was a
Okay.
very very good segment. And I usually tend to be very confused, but now I think I'm very very confident in this type
Oh,
of.
fun.
I really
On the exam, you'll be perfect.
appreciate you so much. But please, always I will be coming into your sessions all time.
Awesome. I look forward to
Wow,
seeing you.
more often.
All right. Thanks for coming, Alvin.
So
I
much.
look forward to seeing you next time.
You have a good day.
You too.